I'd like to bring your attention to a notebook that I'm providing you called the Pandas Package Overview. You'll see it in today's agenda. If you click into this Pandas Package Overview, there will be a lot of material for you here to review after class, especially if you're interested in taking this the farthest that you can, learning as much as you can about data frames and pandas. So let's see. I just want to show you the structure of this notebook, and then we're going to do a lot of this hands-on. So there's a lot of concepts in here, but we'll take care of them in a hands-on way. So when we use the Pandas package, first of all, you'll see some links to documentation. I told you about this data frame data type. It represents a whole spreadsheet worth of data. We can arrive at that data frame by reading a CSV file. So we'll do that in a sec using the Pandas read CSV function. If we want to use the read CSV function, we'll import that function from the Pandas package, and we'll invoke that function, and we'll pass the name of the CSV file name as the only parameter into the read CSV function, and that will give us a data frame data type. We'll work with data frames in a sec. So that's one way of getting a data frame, is this magic read CSV function that we will use in a few minutes will give us a data frame as a result. So that's what we could do to convert a raw CSV file and into some Python object that we can start using this read CSV function from Pandas. Once we have that object, we can ask, well, what data type is it? And we'll learn that it is a data frame data type. And we'll start working with those now. And you'll see this section at the below about using data frame data types. So before we get into using data frame data types, let's just show you all the different ways we can arrive at one. One very popular way is just by reading a CSV file, we'll get a data frame. But if we have our own data, like in a list of lists format, that's one of three eligible formats for us to construct our own data frame using the data frame class constructor. If we want to do it this way, we'll need to import this capital D, capital F data frame class constructor. It's kind of like a function. And we'll pass in our data as long as our data is in one of three eligible formats. The first eligible format is like a list of lists, which we don't really work with that often. It's not very helpful. We can pass that into the data frame class constructor and get a data frame object back. The second eligible data structure to pass into the data frame class constructor is a dictionary of lists, where the column names are denoted by the dictionary's keys, and the values are like the values for each column. We don't generally have our data in this format either. I'd say the most popular format that we generally use when we're working with data is what I would call the records format. In other words, lists of dictionaries. When we were doing the groceries exercise, we dealt with those products variable as a list of dictionaries. So we're familiar with that by now. And as we saw in the brief example that I showed you from the charting notes, where we pass a data frame into the charting function, it's this list of dictionaries that I think is the most popular format of data that we can pass into the data frame class constructor to get a supercharged new data type called the data frame. So how do we get a data frame data type? One, we could read a CSV file, or two, I guess if our data is in one of these eligible formats, like the list of dictionaries, we can pass that to the data frame class constructor. All right, I just talked about this. I'm sure like some of it may be going over your head. No worries, let's practice this a little bit. as we revisit the chart gallery exercise. What I'd like to do with you is create our own data frame from some of the charting data that we had been working with previously, like our bar data or line data. And we'll see how we can convert that data from a list of dictionaries into this new supercharged data type called the data frame. And then we'll plot that really quickly. And then I'll show you some of the popular things that we'll do with the data frame data type as well. And we'll transition into using data frames a little bit. So let's revisit our chart gallery exercise. Previously, we made a line chart and a bar chart. Let's just go with this line chart data, I guess. So I'm just going to continue working in our chart gallery exercise. We have this line data. So I'm just going to run this cell that has this line data variable. And last class, we saw this is a list of dictionaries. So it is one of the eligible data types for us to create our new data frame with it. So let's do it. Below our solution from last time, I'm just going to make some new code cells. We have our line data. It's a list of dictionaries, but let's supercharge it up a little bit. Let's import the data frame class constructor from Pandas, pass our data in, and we'll get a data frame back, and we'll start seeing what this object is about for the first time. So we're going to be using this third-party package called Pandas. We know with any third-party package, in order to use it, we'll have to first install it. So is Pandas installed in Colab? That's a question we should ask before we try to use Pandas. All right, we did this last class. What's the question? What's the code that we'll write to ask? Well, what packages are installed in Colab? Perfect. Pip, the Python package manager tool. Let's list all of the currently installed packages. And since this is a terminal command, like a command line command, in order to get this to work in Colab, we prefix it with an exclamation point. So this isn't a Python thing, it's a terminal command, it's related to Python. All right, cool. What packages are installed? We can just scroll through them. Here we see that Pandas, somewhere in here, Pandas is already installed. Since it's like the most popular package, we could assume that in Colab, it will be among the most popular packages that they've already installed for us. So we don't need to pip install Pandas, that's done for us. We have Pandas installed, now we can just use it. But like the Plotly package and like those other modules that we were using, random, statistics, math, OS module, we still need to import the functions and capabilities. So Pandas is already installed in Colab. Great. Let's use it. So we can import Pandas. Some people like to alias it as PD. You might see that a lot. And if in that case, we would say PD dot blah, blah, blah. In this case, I just want to use the data frame class constructor. So we'll just say from Pandas, import capital D, data, capital F frame. It's important to use capital D and capital F here with this data frame class constructor. Classes are like functions, but they're different, and it's not necessarily a beginner concept. We might get a little bit into classes next class, but we might just skip them. We could treat this like a function. Like we need to pass some data into it and we'll get a result back. So what we'll do here is store this in some new variable, maybe called df equals. Now we'll invoke this data frame class constructor. And when we're doing this, we say, hey, we want to create a new object of the data frame data type. So we know that we work with a number of different lists, but at the end of the day, they're all just a list. So we can treat them similarly the way we would treat any list. Same goes for other data types. And so same goes for the data frame. Since our line data is a list of dictionaries, it is an eligible format for us to pass in. So we'll just pass in our line data. And now we can just look at this df variable, maybe also print what data type is this thing. And that's a good way to get started. All right. So our data went from list of dictionaries to this like tabular spreadsheet looking structure. So when we just mention the df variable, any data frame data type, if it's the last thing we mention in a cell, we get this nice looking output of it. I just want to pause here, see if there's any questions so far. And I'll drop this in Slack. Revisiting our chart gallery exercise from last class. All right. Now that we have this data frame data type, it gives us some supercharged capabilities. And you'll read about these in the Pandas package overview notebook. So, what are these capabilities? The data frame is like it's like a list of objects, essentially. It's like a list of dictionaries. There are X number of rows, or I should say we have rows and columns here. So the way that we'll count the number of rows is actually by passing this data frame into the len function, which hopefully shouldn't be that bad. We know we could pass a list into the len function. It'll show us how many items are in the list. And so when we pass a data frame object into the len function, it shows us how many rows there are. So that might be helpful. But we know with our tabular data structure, we also have a number of columns. So what are the columns? The data frame has a property called columns. So we're starting to deal with its supercharged capabilities here. Like it knows what its own columns are. So we could say df.columns. And here we see two columns. One is called date and one is called stock price, USD. So I think those are some popular things that we would do with the data frame. Data type. How many rows? What are the columns? And now we can use these column names using a dictionary-like accessor approach, where we'll say data frame, square brackets, quotes, and then the column name. And instead of giving us a single value, it will give us the entire column worth of values. So if we wanted all the dates, we would say df, square brackets, and now the column name in quotes. And it's kind of like a dictionary in the way that we're referencing one of the columns. But since this is a data frame data type, we're actually referencing this entire column worth of values. So here you see all the dates. And now we could treat this as almost like a list of dates. Same thing goes with our other column, stock price USD, I guess. All right, so we have a column worth of dates, a column worth of stock prices. We could pass these to our charting function. We'll do this two different ways. We'll pass each one of these to our charting function. And I hope you'll see that we didn't have to map. We didn't have to do a mapping operation to arrive at these, just the stock prices or just the dates. We're leveraging some of the capabilities of this data frame object. We're saying, hey, give us all the values in column XYZ. Before we move on from this, let me just put the point on this that these, I guess, dates equals df date, and prices equals DF. What was it? Stock price USD. I'll share this in Slack in a sec. What data types are these columns? Print, what data type are our dates now? And what data type are our prices? When we deal with an entire column worth of values, it's kind of list-like. We could maybe expect that it would be a list of values, except it's not. It's actually another data type from Pandas that we haven't worked with yet, called the series object, which is like a supercharged list. And we'll see some of the supercharged capabilities of this list in a few minutes when we transition into the CSV processing exercise. But right now, the reason why we're in this chart gallery exercise is to just show the integration that Plotly has with these data frame objects. So if we have this data frame, we passed in our raw list of dictionaries, converted it to a supercharged data frame data type. We can access each column worth of values using dictionary-like accessors. And now we have a series, which we'll work with in a sec, but at this time, we're ready to chart this data. And we can chart it in two different ways now. So I'll just copy the same Plotly code from before. Before, we passed just our list of dates and our list of prices, so we can do that here too. It's just that we've arrived at the dates and prices without doing our loop, without mapping. We just reference a whole column worth of values. So what we could do is like the same as before with our new dates and prices. That should work. We can pass these series objects to the X and Y values as well. So this still works. But the reason why I wanted to even show you this, I guess, is to also show you that there's a tighter integration where instead of passing just the dates as raw values and the prices as raw values, if we pass our data frame as the first parameter, now our X and Y corresponds to column names in that data frame. So the column name, I think, was date and stock price USD, and that will work as well. So, all right. I just want to pause for a sec. Before, when we were charting, we needed to do a mapping operation to get just these lists of simple values from this more complex, like nested structure, maybe a list of dictionaries. And when we did that, we just passed those lists, the list of values, to the X and Y parameters, and that's all good. But we needed to do a mapping operation. An alternative way is for us to convert our data into a data frame data type, which allows us to reference an entire column worth of values at once. And now we can just pass column X to the, or column of date to the X and column of stock prices to the Y. So we don't have to go through that looping and the mapping. Here we have our list of values essentially. It's like a list, but it's supercharged. It's a series, and we'll deal more with series in a few minutes. And we could pass those to the X and Y. They're list-like, so that works too. Or to complete this integration, if you want to be data frame oriented, you could also just pass the data frame, the entire data set, as the first parameter to our Plotly charting functions. If you do it this way, now we're just referencing certain column names on the data frame to chart. All right. So, questions, thoughts? Okay. So now let's move on a little bit. we're done with our charting part of class. We learned there's different ways for us to chart the same data, I guess. Let's do some more fun stuff though.